Hi, and welcome to our book review of Deep Learning in Production. I really like this book because it provides something I think we're sorely lacking in the field of deep learning right now, and that is a definitive guide to best practices. A lot of other fields like software engineering or network security, they're going to have just tons and tons of best practices accumulated in really great guidebooks for you to use up front. If you're a beginner and you hop into those fields, you'll be given access to the wisdom of the ages right up front. But if you're a beginner in deep learning, we're probably going to toss you into a big pool full of academic papers and hope you sink or swim. That's really not effective. So I'm really glad someone took the time to actually accumulate and compile all those different tips and tricks into a singular text. So to that end, let's take a look at the 6 top tips/tricks that I learned from this book. And so hopefully you can decide if it's the right one for you and if your workflow would benefit from some of this knowledge. The first tip is to take a look at data or to view data as a moving target. In research, we're often using data sets like MNIST or SciFar, and these data sets are fixed up front, which is great for us because we don't have to worry about adversarial examples. We don't have to worry about people changing data behind our back. We don't have to worry about the data fundamentally shifting partway through. We can count on the data to be consistent throughout the entire model training process and also the verification phase. In production, however, you're not always going to get this guarantee. There'll be tons of times when you really need to think about how is the data going to shift? How is my model potentially going to drift over time because of all the different examples it's getting? This book provides some helpful tips and tricks to help you avoid that. It's definitely an instance of something where you want to think about it up front, like what kind of model architecture, what kind of resources are going to help me prevent this from becoming an issue down the line. A little bit of effort up front can save you a lot of heartache down the line. The second tip/trick is to use free or otherwise cheap cloud resources over local resources. This is a pretty much a no-brainer, but you'd be surprised how many people insist upon using like an expensive rig that they keep in their corner, which heats their house to unfathomable levels and racks up ridiculous energy bills simply because they like having their own hardware on site. I'm not a big fan of this. I think it's a pretty large waste of time and energy. Not only is it going to be super expensive, but you're also going to have to worry about things like library compatibility, optimization, things that the cloud will just take care of for you. So the moral of this story is unless you have a security reason or you're working with sensitive data of some kind, take advantage of cloud resources. Take advantage of the effort that really clever Google/Amazon engineers have put in beforehand. You don't have to repeat all that work yourself. Your job is to do excellent deep learning. Okay, so tip 3 is the importance of containers. I feel like a lot of people choose not to use containers or find them a necessary step or want to rush their model from a Jupyter notebook to a Python script and just ignore the containerization process. This isn't so much an issue for people who actually put things into production as it is for researchers, but even for researchers, containers represent a super useful tool. They're a way to make sure that people can reproduce your results, which is an invaluable resource in science. I think a lot of the people not wanting to use containers is related to the fact that there isn't like a Docker class taught as a mandatory class in most CS programs today. Even though there probably should be, we just haven't caught up yet. So containers and container orchestration are often left by the wayside when they should be embraced up front as an excellent way to save time and energy. The 4th tip is related, and that's to use a deployment that has built-in scaling. This is another example of where a little bit of effort up front, a little bit of insight to begin with can help you massively down the line. So you may be tempted to just throw your deep learning model onto Flask and get people using it right up front, but you have to think about what happens if I get 100,000 requests on the line? What happens if I get 1 million requests on the line? What happens if this whole thing just blows up? Do I have access to a cloud provider that can provide horizontal scaling, provide access to more and more instances of my model if I need to? And the answer to that question should be yes, especially if you don't really know how many users are going to end up hitting up your application after you launch it. So definitely think about what sort of upscaling your model has access to natively on whatever deployment you're using. All right, so the 5th tip is writing deep learning production code is different than writing research deep learning code. This might sound like a no-brainer, but once again, it's actually quite nuanced. When you write code in deep learning for research, typically you're writing in a very Pythonic way, lots of functions. You aren't really defining a lot of custom objects. You're making use of a lot of libraries. But for production, you're going to want to roll back a bit away from Python and a bit towards Java. And that's so that you can do things like debugging and changing your model in production a lot easier. So you're going to want to do things like define your own trainer class, these sorts of things, because it's going to make it so much easier to procedurally and modularly change things after you've launched into production. And in a lot of cases, it'll also make things easier from a debugging standpoint to include things like unit tests and integration tests and being able to use mock objects when you're actually designing your application. The sixth tip is to not completely write off end-to-end pipelines. This is something I'm guilty of. Whenever I hear someone say, something about SageMaker or Vertex AI, my intuition is to be like, those are amateur tools. They're not for us, we're the professionals, right? Those are for people who are scared of code, who don't understand, all the steps that go into making a really robust and good deep learning model. To put it in context, stuff like SageMaker and Vertex AI are going to let you go all the way from defining your model architecture to deployment without addressing a lot of the nitty-gritty details yourself. So in other words, it gets you to an 80% solution very rapidly. All of my little petty gripes aside, there's a lot of really great reasons to use a resource like this. If you're constrained in terms of time, if you don't really have the expertise on your team, if money's not a big issue for you, these are all reasons why you might want to use a solution like SageMaker or Vertex AI, as much as I am averse to them. So who should buy this book, Deep Learning in Production? I think that there are two groups that are really going to take a lot from this book. And the first is software engineers who may have, or DevOps specialists, who may have a lot of experience deploying different things to the cloud, but they don't really understand how to deploy deep learning models. They want to know what's different, what makes deep learning tick in a way that's different than potentially any other application they've built. This book will provide a lot of insight on that. The second group is deep learning researchers who maybe haven't launched almost anything into production, and they really want to know, how do I take my research code and make it accessible to a much wider audience? This book is going to help answer a lot of those questions. Lastly, I want to say, if you are a beginner and you want to pick this up as a starter guide, like I said, it's going to help you understand a lot of those best practices up front. Just one thing, definitely pair it with an intro, like an intro to Tensorflow or intro to PyTorch. That way you aren't confused when it starts picking apart different kinds of objects in the code here. So when you see something like a trainer object or what it means to fit a model, you aren't inherently confused. This book uses TensorFlow as the library of choice, but it's pretty easy to understand where the relevant PyTorch would come in. All right, so that is my review of deep learning in production. I recommend it, and I hope that you gain something from this video.